Hello everyone. First of all, I want to thank the International Institute for Plan Engineering and Design for the opportunity to share with you this keynote focus on quantum technologies for plan engineering. So everyone is hearing about quantum computing or quantum technologies in general terms in the media, newspapers, etc. But why are we talking about this and why are we talking about this now? You know, there is a clear security threat that in fact has been identified. Just only for your understanding, in classical computing and breaking a current key could take billions of years of the computing in a typical laptop or something similar. For a quantum computer, the same breakage of the keys will take seconds. That is creating some nervousness, as you could imagine, for the responsible of the security worldwide, and there is a clear message to urge the transformation and modification of the cryptography that currently we using. We will talk about this in some minutes. But not only that, because our industry or economy needs growing, computation power. With the current classical environment, we adopt and we use parallel processing, or we adopt cloud computing and distributed computing, all several tactics. But there are some kind of problems that has no solution even using those accelerators, and need extremely high potential of computation. That's, for instance, the typical problem of the roots of the tracks on nodes. So if you grow the number of nodes, the combinations of the optimal route is growing exponentially. For instance, 16 single points of contact on this network will mean billions of combinations, and if you grow that, the explosion is amazing. So computation power is needed. And last but not least, we are discovering new features or new technologies that are allowing to do things that we didn't know a few years ago. And this is the case, for instance, of some of the application of the quantum technologies in general terms. We will see this after too. And why no? Because the level of maturity of the technology is allowing us to pass through the typical or pure lab to the production or the industry. And this is true in different extension, depends on the technologies. But as Chuan said, that we have a dream, that the physics has a dream or had a dream more than 100 years ago, when the Solvay meeting, the best collection of Nobel Prize, was thinking all of them, or most of them, on quantum, in quantum technologies, in quantum physics. And today, this is a reality. That quantum physics has been converted in quantum technologies in general terms. So it's no longer a physics stream, but this is real an engineer's nightmare. Because the problem today for scale this up, and we are in different level of advance, is an engineering problem. Apart of that, during this year, the United Nations declare this the year of quantum science. So the awareness is clearly on the table, and the call for action to the governments, to the citizens, to the enterprise are there. So the moment is now. Apart of that, we are in a curious situation, because we are in a geopolitical war. In this graph, you could see the investment, the public investment that every country has made for this type of programs, and you could see billions of dollars. For instance, the States has invested more than $7 billion, but many other countries are launching program very ambitious on investment. China is recognized like probably the country that's investing more. They are talking about 15 billions, 15 billions, but difficult to check. They are saying that the investment they are doing is not so high. You could imagine that there is a lot of versions of this investment. But in European countries, the Western countries, those amounts are accurate. That are the amount that has been committed by the governments for investment in the next year. For instance, Spain delivered their own strategical plan a few months ago, and they have committed more than 1 billion euros for this program. So it is quite significant. As you could see here, the amount is not talking about millions; they are talking about billions typically. But this geopolitical war is not only about the money you have put on the table. It's also related with the impact on publication, knowledge creation, talent generation. And for this situation, Europe is the number one globally. It's the highest concentration on this talent in the population. When we are talking about not just pure investment analysis, investment or development of knowledge, and we move to the innovation, the commercial application of that, and we are measuring the patents, the landscape is totally different, because here the number one is States and China, competing among them to achieve the highest level of patents, to cover and to fulfill the market with their own innovations. So this is a lesson learned. Europe has to put more attention on moving the new knowledge they have generated to innovation in the market, to not being put off of the game. And not only that, because we could also control and measure the number of companies that have been created, typical startups or other initiatives around these technologies. Here, once more, number one on generation of companies are the United States, and followed by the rest of the Anglo countries in general, such as Canada, England, etc. And what are the technologies that we are describing as quantum technologies? This graph comes from the European community. They are using these for describing the different technologies, and this is quite Cartesian, organized, and I love. So we will use that for explaining. Distributed the technologies in 4 blocks. The first block is quantum communication, including crypto. The second block is sensoring and metrology. The third block is the quantum simulation, where we are using quantum computing capabilities to simulate the nature, and this is very converged with quantum computing, the pure quantum computing. Let's do a quick review of any of them. When we talk about communication and security, what we are talking about? We are talking about, in one hand, the capabilities to create new networks of communication using technologies that is around quantum physics. Let's say we use quantum physics effect. For that, we have specific devices that allow us to construct networks that are secured and are controlled under the quantum effects of the physics we use for that, or even devices that are using those effects for a specific usage. Like, for instance, the QRNG is quantum random number generator that has companies and devices specifically. This, for instance, is very useful for security or for synchronizing elements that are remote, etc. That is, with those bricks, we are constructing a new network that is the future quantum internet. The initiative in Europe is named EuroQCI, and they are involved most of the European countries. Every country is creating their own nodes. Those nodes are going to be connected and locally, at country level, and international with the other nodes. This is the first seed for creating an alternative quantum internet. The investment is quite high in this area too. Chinese and Americans are also playing with that, creating a specific network. The Chinese is a more significant example, because they are creating probably the more dense and long network, communicating points that are far away compared with the ones we are managing here in Europe, and even using satellites for completing this network. They are creating a specific technology for replicating the signal, repeaters, and they're advancing quite well here. And for instance, in every of these nodes, you could see configuration like this one. This is the network created in Madrid years ago by the Polytechnic University and several companies, that has connected several nodes and several data centers with Fever, that typically we are using public Fever, demonstrating that we are able to use the current infrastructure for applying these new technologies. Okay, and what's about the crypto that we have also mentioned? The big question: when will we able a quantum computer for breaking the RSA? RSA is the typical algorithms that we are using universally or quite universally for creating the security or cybersecurity around our systems. No one's know, but it is clear the threat is there because, for instance, the big powers, and this is the deadline that the Americans has put. It is 2035. Anyone that wants to connect with the federal or the American government, North American government, need to be updated to a new crypto systems that is named Post-Quantum Cryptography before 2035. And this has, as you could imagine, a domino effect. Everyone that is connected with that need to be connected with others. So the interest is not just the connecting with our government, is the connecting with any ecosystem that today is guaranteed by the current crypto. But tomorrow we will see the threat of the quantum computation for breaking those cryptos. So this is described in the Mosca diagram. Mosca is a university professor lecturer in a Canadian university, described very clearly that the migration time plus the self lifetime of the data, the data, the time needed of that information will be encrypted. It's much longer than the threat we have, the threat timeline that we have with this technology. So everyone is in risk today. And we are start seeing terms like post-quantum cryptography, or you will be familiar with the NIST PQC challenge. That was the initial seed for creating the new family of algorithms. Was a survey that the NIST launched several years ago. They finally present 4 algorithms, and that 4 algorithms is going to be installed everywhere. The program or the project on installing and substitute or alternate the classical and quantum cryptography or post-quantum cryptography, in many cases, this is another term for you, is crypto agility. The crypto agility is the project for install this in the organization. And this is something that is today happen. Most of the big organizations are doing currently this. And this is also true. Everyone is harvesting all the information with the idea of decrypt later when the quantum computer will be available. That information is not public, but I have harvested that and I have stored that, and we will decrypt later. This is something that is the mantra of most of the power of the security forces, military forces, etc., that are doing this way. But not only, because also the companies are doing something similar related with the communication and security for the competitors. Okay, what's about sensing and metrology? It's very interesting because this is probably the more mature discipline on the technical and the quantum technical environments, and has tons of different applications. For instance, here you could see some of the devices constructed with these technologies that are in the same line of some of the devices we have currently in the market, but the power of these devices is the accuracy and the on the signal they could capture, that this is ultra sensitive. For instance, they are using these technologies for spectrographs or for radars, new family of radars, or for gravimeters or magnetometers, that are some of the applications that probably will be more interesting today on the market. On for specifically or industries, the detector, the last one at the right, the gas detector, chemical sensor, and thermometer. And in fact, some of the use cases I have found that is in the area, industrial area that we are all of us interested, for instance, industrial and petrochemical. I have seen cases of analysis of gases, or for elements like benzene, acetylene, or detection, chemical detection, or for measurement of magnetic fields, for controlling the temperature, or for making quality control, this type of stuff. And at the end, this is a couple of samples that have been published in the media, where one of them, the first top right, is describing the agreement that the U.S. government, in this case the geological organization, has signed an agreement with Q-Control. That is one of the companies specializes in this type of sensor for improve their processes. Or the bottom right, that this is a sensor that is able to substitute the GPS in military forces, as you could imagine, and we see every day in the in the media the importance of the GPS for guiding the airplanes, missiles, etc., etc. Imagine that you are destroying the GPS, you are closing the eyes of your enemy, but you have alternative. You are managing this technology for substitute GPS with advantage. And this is a reality because they are putting this on board, on airplanes, on ships, etc., etc., in the army today, in the British Army today. Okay, and what about quantum computing and simulation? That is probably the highest promising and the people, big hope. Everyone is asking, okay, but this is powerful, but how powerful it is. Probably you remember when you were young that someone counts out the tail of the grain of wheat in the first square of the chess table and so on till the last one. We are talking about 2 up 64. 2 up 64 means more than 1,500 times the global production of wheat in the globe. So you could imagine the number of elements that we are managing there. Every grain of wheat for us is a element of calculation for the similar I'm going to make in the following. Here's the similarity with the size of the space or the storage. 2 up 64 is close, is before a zettabyte of capacity. But imagine 2 up to 280 means the number of atoms of the universe. And this is just only for understanding what is the power of calculation of the technology we are describing. Today we have machines with more than 1,000 qubits. 1,000 qubits means 2 up 1,000 evaluation at the same time in the same nanosecond. So you could imagine the force, the brute force that we have available managing this type of computing, of computers, for solving problems that today have no solution using classical approach, because the number of combination is so high that it's impossible to cover everything. But now it is possible, and tomorrow will be even more possible when the number of qubits will grow. But it sounds enormous, marvelous, but as you could imagine, not everything is perfect. We have in the evolution of this technology, it is quite immature, and we have a lot of errors. We have problems of scalability. We have problems in the hardware development. Imagine we have not discovered so far the transistor, the quantum transistor. So we are not able to scale this up at the level we are doing, or we did that in the classical computing. So we are waiting for this discovery and this engineering development for making this less handmade and more industrial. But don't forget that this is just only the hardware part problem, because we need to develop the software, the new software. We have to integrate with the classical computer. The quantum computer is not going to substitute the classical. It's going to coexist. It is important to create those interface and the architecture to support the communication and the correct communication between both. And the training people is another big problem today, because the scarcity today is high. I could imagine when this will explode in the next few years. The talent will be the bottleneck for the development of this industry. And for what we could use the quantum computing? Because that's the typical question. Okay, there are 4 families of solution or problems to solve. The first one is the acceleration of the machine learning, the artificial intelligence. In fact, today's case is, you probably have heard in the media that this is an enormous hope. The acceleration using quantum computing of the training of the model training, that today is one of the bottlenecks we have in the development and deployment of the artificial intelligence. There are today some companies that using quantum and using quantum inspired programming are able have been able of reducing the learning size and improve dramatically the training of the models. That this is a reality that is there, but the people continues analyzing this because the promise is enormous. Optimization, the second family of problems to solve, and today is probably the more feasible to put in practice. The typical problem of the traveling salesman or the track route that I showed to you before, scheduling, logistic, planning, this type of problems, when the number of elements the explosion of combination is enormous. Is the typical ones where using the force root of the quantum computer could be solved in one shot. Another family of problems, or another family of solutions that quantum computing offers us is the simulation of the nature. That's typically a very complex system or very complex storage of these for chemistry or material science or design of drugs, this type of stuff. And finally, the cryptography we have mentioned before, that this is the threat for the current system or the current cryptography. This is a sample, for instance, of the use cases of pharma. The area that could be more interesting for us is related with the plant engineering and so on. That could be related with the production, the logistic, and so on. There are a lot of reports that has identified use cases where they have impact. The quantum computer could have impact in improve, accelerate, or even make things that we were unable to do so far. And this is something similar for chemistry industry. You will see, you find for many other industries, banking, utilities, communications, etc., etc. There is a lot of papers, a lot of documents and reports that are describing the opportunities for applying these technologies in multiple different industries. And some samples, for instance, Fujitsu apply their own technology. Fujitsu, one of the vendors on quantum computing technologies, they apply their own technologies in their own manufacturing plant, and they obtain just only a 40% of advance and savings on the movement of the robots and the time, reduction of the time of the operators of those robots. 40% sounds good, and the saving, talking about millions. Or, for instance, the case of BMW. BMW has multiple teams working on parallel in different areas of the fabrication of the cars. In this case, they published one of the paper describing the usage of the quantum computing in the vehicle design and manufacturing. They say that they obtained simulation 30x faster, 30 times faster than the previously, and that means that they need to construct minimum or fewer physical prototypes, with the saving that means. Obviously, this is just only one of the multiple perspectives of the potential use of the quantum computing in this industry. Another case, in this case, related with the hydrogen production in a well-known company. Or this case that this is quite curious is the construction of the digital twin using quantum computing. This was an experience in 2022 of Bosch and Multiverse, and the idea was increase and reduce the waste of the production or the construction of the management of this digital twin. I have not tracked about after the launching of the project or the finalizing of the results of that. And what's about the market? This is extracted from a report from McKinsey that this is well known in the quantum environment, and they describe that in 10 years we are talking about, in the pessimistic point of view, 28 billions of dollars related with quantum computing, till 72 billions in the optimistic point of view. And why we have this enormous range? Because the hardware has limitation, as we have seen before. It depends on the hardware evolution. We will achieve the pessimistic of the optimistic. Similarly, in communication and sensing, the range in communication and sensing are smaller, evidently, because the level of maturity and the predictability of the results are higher. But we are talking in all the cases billions, and if we move to the 2040, in 15 years, we are talking about a terrific technology. Enormous impact in all the industries. And one of the features of this, that this is not focused just only in one industry. This will be transversal. All industries will be impacted with quantum computing, or quantum communication, and quantum sensing. And last but not least, what about you? Okay, if you decide to start the journey on movement of this, what are the steps recommended for making this? The first one is you need to study, because this is not obvious. The technology is absolutely dramatically different than the ones you have seen before. You need to connect with the ecosystem to find partners and to learn. After that, typical suggestion, and my suggestion is create a multidisciplinary team inside your organization in order to train the people on these technologies and to find the right partners for helping in the development of the program inside the company. Involve your business teams. That the business team are the people that has the real problem, the problem that need to be solved, and connect with them in order to identify what are the problems that could be covered in a better way using these technologies. Once you know what are the usage of that, obviously, once identify the use cases, put the hands on that, execute, construct the solution, and demonstrate that this is feasible. For that, you will need to win the trust of your business areas. And then once it will be demonstrated, just scale up, define a strategical plan, a growth, and execute. This is simple and as complex as simple. So in summary, the quantum revolution is coming, and this is disruptive, and it will be disruptive in the next year. The question is, we are living in a real commercial and geopolitical war, and this could mean limitation to access to the technology, or even problems for commercialize some technologies outside your area. And this is more and more clear every day. The degree of advance of the different technologies, the maturity of that is different. You need to be aware of that. Obviously, it's not a question of when this is going to happen. No one knows when in the next few years. But the question is who, if you are going to be part of this who, and how to implement that in your industry. Another point is take into account the talent scarcity, and you need to create your own teams or find help for putting this in life. It's very difficult to re-skill people with the classical computing to the quantum computing. Could be feasible, but it could take a lot of time. And effort. Many cases we have seen new people involved on that from scratch, and we have a problem because we have no degrees in the university that's delivering this type of skills. It's something that so far need to be created internally in the companies or in the organizations and reinforced with PhD or with expert extracted from the multiple master programs, more theoretical, more practical that exist in the market today. And if you have not started, this is the moment to start. Don't wait more. The problem we are living in many cases, we typically tend to overestimate the impact of technology in the short term, and we underestimate the effect in the long run. And this is a normal risk for quantum technologies, because this is a long run, it's a marathon, this is not a sprint. This is not the race of 100 meters, it's the race of 42 kilometers, and we need to be aware of that. The executives are understanding these problems and these risks, and they are saying in the surveys that we could have a lot of opportunities of failing if we are not taking into account these technologies in their plans in the near future. But the big question, and the big question for all of you, is what are you going to do once you know all the things you have heard today in this session? Thanks very much for the attention, and welcome to the Quantum Decade. Thank you.